June 9 here, we're asked to solve this here to find all the values of theta between 0 and 360 for this here. Notice we have a double angle situation going on, right? So we need to write the double angle for that. And remember, okay, sine 2a is equal to 2 sine a cos a, right? So when I got sine 2 theta, I can rewrite that as 2 sine theta cos theta. Okay, that's what sine 2 theta is, using the double angle rule. So you got to use your double angle rules in these questions. And then, of course, that becomes 6 sine theta when I times by 3. And what I'll do is I'll take that 2 sine theta over, so it becomes minus 2 sine theta, and that will equal 0. What I hope you notice then is, if you notice these here, two terms, there's a common factor of sine theta. Okay, because we've got to somehow solve this now, and it isn't in a quadratic form, but you'll notice there's a common factor of sine theta. So I can take sine theta out, and what do I times by sine theta to get this? Well, it'll be 6 cos theta. And what do I times by sine theta to get that? Well, it'll be minus 2. So I'll either have then, right, because I've got this times bracket equals 0, something times something equals 0, either the first thing is equal to 0, or the second thing is equal to 0. Okay, if sine theta is equal to 0, it's really easy because you can draw a simple quick graph for that, right? Okay, it's quite a flat sine graph there, but when it's equal to 0, okay, it's these important values here, isn't it? Okay, right? Obviously you need all the values between 0 and 360. So it'd be that one there, which is 0, that one there, which of course is 180, and that one there, which is 360. I mean, you could do sine to the minus 1 of 0, couldn't you? Sine to the minus 1 of 0, and you get 0 out. But you need to get the other two values as well, right? So just draw a quick graph, and it's easy enough. This one, if I take that minus 2 over, it becomes a plus 2. And then, of course, you take the 6 over and divide, so it becomes 1/3. So cos theta equals 1/3. So there I need to do theta equals cos to the minus 1 of a third. Okay? And I can determine that in my calculator. So make sure you're in degree mode, and I get out to be 70.5 degrees. Okay, now we need to draw the graph here of cos x then to actually work out what the other values are. So maybe every 2 centimeters represent 90. So 90, 180, 270, 360, and 1 minus 1 here. Okay, so cos 0 is 1, cos 90 is 0, cos 180 is minus 1, cos 270 is 0, cos 360 is 1. And then when it's equal to a third's about there, isn't it? Okay. So we can see then our angle that's the 71, and then this one here, to get this one, using symmetry, of course, it'll be 360 minus it, okay? So remember, you only use, when it comes to symmetry, you only use the 180 or the 360, okay? So only those two. Never use 270 or 90, but actually with cos, is 360 we always use, right? So it's easy enough. You could see there going across to 70, so we're going back then, 70 from 360. So the angle there is 70.5, and the other one will be 360 minus 70.5. So in total then, all our angles will be theta will equal 0, 70.5, 180, okay, that one then will be 289.5, and then 360 to finish off, okay? So you've got all those angles there.